Welcome back to Applied Algebra and Trigonometry. This video will be a little bit different. It kind of fits actually between 9.2 and 9.3 in our book, but I'm going to talk with you about reference angles. All right, so what is a reference angle? Well, if you are in quadrant 1, it's the angle you're given. Theta equals theta reference. It is the reference angle because you can drop a line down to the x-axis. And if this is, say, vector A with a magnitude of A, this would be A sub x, this would be A sub y, and the standard angle would be the angle you were given, theta. Cool. And we could do, we could calculate A sub x as A times the cosine of theta, and A sub y as A times the sine of theta. But what if the vector isn't in quadrant 1? What if you're in quadrant 2? Okay, we have a vector in quadrant 2 with a standard angle of theta. There are a multitude, there are an infinite number of component vectors into which we could break this. However, we're looking for x and y components. Well, we could break it into this horizontal component and this vertical component, but those aren't the ones I want you to do. I want you to use this vertical component and this vertical component and make this your reference angle, not this, okay? Never that. You are always going to drop a line down to, or up to, as you'll see in a moment, the x-axis, okay? That will be your reference angle. None of this stuff, okay? None of that. Forget those yellow marks there. What about quadrant 3? All right, well, what about this case? Surely that vector is so close to the y-axis, we could draw our horizontal component there and draw our vertical component this way, but no. In this case, you have to draw a line. Think of it either as going up to the x-axis or down from the x-axis to the vector. I don't care. Connect the tip of the vector to the x-axis. And that is your vertical component. If this is A, then this is A sub y. That's the vertical component. Here's the horizontal component, A sub x. And your reference angle is this angle. This is theta reference. Okay? Let me erase the A sub x. It looks like it's a subscript of the theta, and it is not. In fact, let's see if we can move that theta over to the other side. That's where it belongs. Oh, didn't want to go, did it? Okay, there. All right, so your reference angle is this green angle marked there. Okay, that's quadrant 3. Let's go to quadrant 4. Okay, so if we have a vector in quadrant 4, we are going to do the same thing. No matter which of the axes it's close to, we are going to connect the tip of the axis with the tip of the vector with the x-axis. Now the standard angle for this vector is this. It goes all the way around in a counterclockwise direction. But the reference angle for this vector is here, theta reference. Also for this vector A, the horizontal component would be here, and the vertical component would be here. Now let's look at these all together, right? When we have them all together, what do you notice? Well, in quadrant 1, our horizontal component of our vector, any vector in that quadrant, is positive, and the vertical component, the y component of that vector, is positive. In quadrant 2, the y component is still positive, but the x component is negative. In quadrant 3, the x component is negative and the y component is negative. In quadrant 4, the x component is positive and the y component is positive. But notice something else about the orientation of these triangles that we've drawn. Oops, I left something there. Can't have that remaining. Okay, that's gone now. Good. So if we color those in, it begins to look like something. A bow tie, because bow ties are cool. So that's a way to remember where you draw your reference triangle. If you have a vector in the first quadrant, drop a line down to the x-axis to form that part of the bow tie. If it's in the second quadrant, drop a line down to the x-axis to form your triangle and your part of the bow tie. If it's in the third quadrant, draw a line up to the x-axis to form your right triangle and that part of the bow tie. And if it's in the fourth quadrant, draw a line up to the x-axis to form your bow tie in that quadrant. Hourglasses are not cool. We have many other ways to tell time. Always use a bow tie. Okay, so mathematically, why is that? Well, it's for this reason. Don't ever do this, but if you were to do this, you remember our formulas? This is a good formula. We have a sub x equals a times the cosine of theta, and a sub y equals a times the sine of theta. Okay, those are perfectly valid formulas. All right, let's see what happens if we misdraw our reference triangle. If we're in the first quadrant and we draw our reference triangle here, so we have this going on. Yes, those are two components of that vector, but if we want to be consistent with our trigonometric formulas, watch what happens if we use this as our theta. The x component is now opposite theta, and we would have to use this formula instead. Very inconsistent. Likewise, the formula for y, we would now be looking at the adjacent side, adjacent to theta. We would have to completely switch these. We are not going to do that. We are going to be consistent. No hourglasses, only bow ties, because bow ties are cool. Our next topic will be vector addition by components, and you'll see how reference angles become important. But that's it for this video. I'll see you in Collaborate.